Hello everyone. Today we will going to see some practice questions from the chapter P block elements. This is part 1. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. So this is our index slides. We will going to see some practice questions from question number 1 to question number 9. Let's start with the question number 1. Boric acid is called acid because its molecule. So you have to select the correct option. The options are contains replaceable H positive ion, gives up a proton, accepts OH negative from water releasing proton, combines with proton from water molecule. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the correct answer. The answer is option C, that is accepts OH negative ion from water releasing proton. So boric acid, due to the small size of boron atom, boric acid is basically BOH whole thrice, right? So B is attached to 3 OH molecules, right? So B is directly attached to 3 oxygen atoms, you can say. So due to small size of boron atom and presence of 6 electrons, because 3 electron pair as uh, the outermost electron pair on the boron and the 3 bonding pairs from the oxygen. So total 6 electron pairs on the boron in the boric acid. Boric acid accepts a pair of electron from OH negative ion of H2O and thereby releasing a proton. Okay, so as boron in the boric acid, the size of the boron is small and it has a presence of 6 electron on it. So it accepts a pair of electron to get stabilized from OH negative ion and OH negative ion from H2O and releasing the proton. Okay. Thus, the C option is the correct answer, that is accepts OH negative from water releasing proton. Okay. Let's move on to the next question, that is question number 2. Heating of an aqueous solution of aluminium chloride to dryness will give. So we have asked that if we heat the aqueous solution of aluminum chloride to dryness, what it will give the product. So options are AlOHCl2, Al2O3, Al2Cl6 or AlCl3. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The answer is option B, that is Al2O3. So, aqueous solution of AlCl3 is acidic due to hydrolysis. You can see that AlCl3 plus 3H2O giving us AlOH whole thrice plus 3 molecules of HCl. So, aqueous solution of AlCl3 is acidic due to the hydrolysis process, and on the strong heating of AlOH whole thrice, it is converted into Al2O3. So, 2 AlOH whole thrice on the heating process, it gives us Al2O3 plus 3 molecules of water. So, the heating of an aqueous solution of aluminium chloride giving us to the dryness giving us Al2O3 in the final as the final product. Okay, thus the correct answer is option B, that is Al2O3. Okay, Let's move to the next question. Question number 3. Boron cannot form which one of the following anions? We have given some anions in the option. We have asked that boron cannot form which of the anion from the options? Options are BF63 negative, BH4 negative, BOH whole 4 negative, or BO2 negative. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option A, that is BF6 3 negative. So you know that boron is having 5 atomic number. That means it is having 5 number of electrons. On uh, on writing or on writing the electronic configuration of boron, it will be 1s2, 2s2, 2p1 at the ground state. And if you write it in the terms of orbitals, it will be 1s2 means 2 electrons in the s orbital, 2 electrons in the s orbital of second orbital, and 1 electron in the p subshell of second orbital. Right? So this is the representation at the ground state for the boron. Now, at the excited state, what happened? 1 electron will move to the outermost orbital. So you can see that this is the excited state representation for the boron. 1 electron from 2s2 is coming to the 2p1, right? And it is becoming 1s2, 2s1, and 2p2. You can see that 4 lone pair is accommodated in this empty orbital 1, 3, 4. So we can accommodate 4 lone pair, and the fourth lone pair is accommodated in this empty orbital. We have this empty orbital here, this box. So the fourth lone pair, which will come because 3 lone pairs we have, right? The fourth lone pair will come in this empty orbital. So maximum covalency is equal to 4, right? Because only 4 lone pair is coming. So maximum covalency will become 4 for the boron, and due to the absence of d orbital, the maximum covalency is 4 in the case of boron. Thus, BF63 negative is not formed, because here you can see that to the boron directly 6 atoms of fluorine is attached, which is not possible, as the maximum covalency boron have is 4. Thus, the compound or the anion which boron cannot form is BF63 negative. Other than that, BH4 negative, which is basically BH3 plus H negative, BOH whole 4 negative, that means BOH whole thrice plus OH negative, and BO2 negative are formed. These are the anions which can be formed easily. Yeah. Okay. And thus the A option is the correct answer. Okay. Let's move to the next question. Question number 4. Mark the oxide which is amphoteric in character. So basically, we have to find the oxide from the options which is amphoteric. Amphoteric oxides are the oxides which can behave either as an acid or a base. Okay. Options are CO2, SiO2, SNO2, or CO. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay. Let's see. The correct answer is option C, that is SNO2. So SNO2 tin oxide is amphoteric in nature. Why? Because it dissolves in acid as well as in alkalis. Okay. For example, if you react SNO2 with an acid H2SO4, it gives us SnSO4 whole twice salt plus 2H2. Right? So it dissolves in the acid. And if you react it with a base like SNO2 plus 2NaOH, it will give us Na2SNO3 salt plus H2O. So it is also dissolvable in the alkalis or base and also in the acids. That's why you can say that SnO2 has an amphoteric character, right? And thus the option C is the correct answer, that is SnO2 tin oxide. Okay, let's move to the next question. Question number 5th. Graphite is a soft, solid lubricant, extremely difficult to melt. The reason for this anomalous behavior is that graphite. So you have to select the correct region for the behavior of the graphite, and you have to select the correct region from the options. Okay, options are: is an allotropic form of diamond, or you can say graphite is an allotropic form of diamond. Graphite has molecules of variable molecular masses like polymers. Graphite has carbon atoms arranged in large plates of rings of strongly bound carbon atoms with weak interplate bonds. Or graphite is a non-crystalline substance. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C, that is, has carbon atoms arranged in large plates of rings of strongly bound carbon atoms with weak interplate bonds. So basically, graphite has carbon atoms arranged in large hexagonal layers with weak van der Waal interactions between the layers. Okay, so uh, graphite is an allotrope of carbon. Okay, first of all, this is the concept, and graphite has carbon atoms in it arranged in the large hexagonal layers with the weak van der Waals interactions. Carbon atoms are attached to each other by the carbon bonds, and the layers of the carbon atoms are attached or are interacted with the weak van der Waals interactions between the layers as mentioned. Thus, option C is the correct answer. That is, graphite has carbon atoms arranged in large plates of rings of strongly bound carbon atoms with weak interplate bonds. Okay, let's move to the next question. Question number 6. Carborundum is obtained when silica is heated at high temperature with. So this is a product, and we have asked that it is obtained when silica is heated at high temperature with what? You have to find out that when the silica is heated with something, like suppose it is X, then this product will form. So what will be the X? Options are carbon, carbon monoxide, carbon dioxide, or calcium carbonate. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option A, that is carbon. So when silica is heated at high temperature with the carbon, the carborundum is formed. SiC. Okay. So SiO2 silica plus 3 atoms of carbon at high temperature, 2300 Kelvin temperature. It is giving us SiC plus 2 carbon monoxide molecule. Okay. So we have asked that when silica is reacted with what to give us the SiC carborundum. So the correct answer is carbon. That is option A. Okay. Okay. Let's move to the next one. That is question number 7. Among the following substituted silanes or silanes, the one which will give rise to cross-linked silicon polymer on hydrolysis is. So we have asked that we have given some silanes substituted actually, from the options. In the options, we have to select the one which will give rise to cross-linked silicon polymer on the hydrolysis. Okay. Options are R3SiCl, R4Si, Si is silicon, RSiCl3, or R2SiCl2. So you have 10 seconds to solve this question. After that, we will see the answer. Okay. Let's see. The correct answer is option C, that is RSiCl3. So RSiCl3 gives us the cross-linked silicon polymer on the hydrolysis. So if we perform the hydrolysis of RSiCl3, it will give us the final product as the cross-linked silicon polymer. You can see the reaction given here. RSiCl3 on the hydrolysis, it is giving us RSiOH whole thrice, and it gets under the polymerization to give us this polymer, which is cross-linked silicon polymer. You can see, right? Thus, our correct option is option C, that is RSiCl3. Okay, let's move on to the next question. Question number 8. The name of the structure of silicates in which 3 oxygen atoms of SiO4 4 negative are shared is. So we have to name the structure of silicate in which 3 oxygen atoms of this species are shared. Options are pyrosilicate, sheet silicate, linear chain silicate, or 3-dimensional silicate. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option B, that's the sheet silicate. The structure of silicates has been found with the help of X-ray diffraction techniques. Sheet silicates are formed when 3 oxygen atoms, bridging oxygen atom basically, of each SiO4 4 negative unit are shared. Hence, the general formula of sheet silicate is Si2O5 whole to the power 2n minus n. Okay, and that's why the correct name of the structure of silicate in which 3 oxygen atoms of SiO4 4 negative are shared is sheet silicate. Thus, B option is the correct answer. Okay, let's move to the next question. Question number 9. In curing cement plasters, water is sprinkled from time to time. This helps in. So, this sprinkling of water into the cement plasters for the curing, it will help in what? Okay, options are keeping it cool, developing interlocking needle like crystals of hydrated silicates, hydrating sand and gravel mixed with cement, or converting sand into salicylic acid. So you have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option B, that is developing interlocking needle like crystals of hydrated silicates. So the hydration of calcium aluminates and silicates, which is basically the sprinkling of water time to time into the cement plasters, and it involved in the setting of cement is an exothermic process. Hence, cement structure have to be cooled during setting by sprinkling water. Thus, our B option is the correct answer.